Hello class, today we will do Lab 6 on VLSM subnetting and classless routing with OSPF. Okay, the first part is on VLSM, variable length subnet mask. Okay, this topic is actually quite important, especially in the VLSM. Okay, so you are expected to know your VLSM, how to do subnetting very well for this lab, for the lab test, and of course for the semestral exam. Okay, now you should have done this in your first networking topic last semester. Okay, so let's do a revision. Okay, the first activity is to calculate the VLSM subnet. Okay, so we have a class C address that has been allocated to us 192.168.10.0/24. Okay, this is the requirement. Perth needs 60 hosts. Singapore will need 30 hosts, Jakarta, KL, and Sydney will each need 12 hosts. So we need to do subnetting of this network, okay, according to the requirement. Okay, let's open up the pen and change the color to red. Okay, let's scroll down. Okay, so based on that, we have to calculate the subnet mask. Okay, let's look at the Perth requirement. Perth requires 60 hosts. Okay, 60 hosts, how many bits do you need in order to create 60 hosts? So you will take 2 to the power of 6. Okay, minus 2. Okay, why minus 2? Remember, minus 2 is to minus away the broadcast address and the subnet mask. Okay, that means we will need 2 to the power of 6. So we need 6 bits. We will need 6 bits in order for us to have 62 usable hosts. Okay, what happens if we use 7 bit? So if we use 7 bit, 2 to the power of 7. Okay, so if you open up the calculator, okay, if you take 2 to the power of 7, okay, so we will have to change the calculator to scientific. Okay, 2 to the power of 7. Okay, 2 to the power of 7 is actually 128. So if we have 128, so again we need to minus 2 to give you 126. Okay, this would be too many hosts. We only need 60 hosts. If we take 2 to the power of 5, okay, 2 to the power of 5, 2 to the power of 5 give us 32. Okay, 32 and minus 2 will give us 30 hosts, which is 2 less because we need 60 hosts. So we will need 6 bits. Okay, so we will need 6 bits in order to give us 60 hosts. Okay, so 6 bits. Okay, if we need 6 bit, okay, we are given this 192.168.10.0. Okay, so 6 bits, meaning that, okay, /24 means that we are going to use 192.168.10. Okay, so this will be the 8 bits that you can use. Okay, so initially the host bit will be 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Okay, but this, if you use 8 bit, this will give us 254 hosts. It's too much, so we only need 6 bits. So 6 bits means we only need up to here 6 bits of host bit. So these two can be used for your network. Okay, so these two can be used for your network. So we'll use these 2 bit for network. So the subnet mask will increase from /24 to /26. Okay, so we only need 6 bits for the host. Okay, /24 to /26. So, which is why we subnet a /24 to /26. When we do that, we actually created 4 networks. .0, .64, .128, .192. Okay, and all of them have /26. Okay, in case you are wondering why 4 networks, because we use 2 bits for subnetting. We borrow 2 bits. When we borrow 2 bits, this will be 00, this should be 0, 1, this should be 1, 0, this should be 1, 1. We borrow these 2 bits. And so this will remain as your network bit. How about your host bit? Your host bit, if it's all 0, okay, when it's all 0, it indicates the network address, if you remember. So the network address of the first network is 0. The second network is 64. The third network is 128. And the last network is 192. Okay, this is how we come up with the network address. Okay, so we borrow 2 bits to do our subnetting, and the remaining bits we set it to 0 to get our network address. Okay, so we take the first network, 10.0/26, and then use it for perf. Okay, so this will be the network address, this is the broadcast address, anything in between we can use it for the IP address. Okay, so perf can use any IP address between .1 to .60. Okay, so this will give us, .60. Okay. So perf will require 60 hosts. These are the 60 IP addresses it can use. Okay, so next, okay, we can do subnetting for Singapore. Okay, for Singapore, okay, we will take the second address, okay, that's available. Okay, the second /26, okay, which is .64. Okay, so for Singapore, we do .64. This is available. .0 had already been allocated to perf, so we use the next one, .64. Okay, so how many hosts does Singapore need? Singapore need 30 hosts only. So just now, remember, we do the calculation. Yeah, if we need 30 hosts, okay, 5 bits will be just nice. So we only need 5 bits. Okay, so 5 bits. Okay, so meaning your subnet bit can increase by 1 more. So this will be your network bit 3 bits, and your last 5 bit will be your host. So this will be your network bits. This is your host bit. Okay, so this will give you a prefix of /27. Okay, so 26 we increase to /27. Okay, remember .0 you cannot use, it had been used by perf, so we start from .64. Okay, so your first network is .64, which is 0, 1, 0, 0, 0, 0, 0, 0. Okay, what's the next network that you can use? It will be 0, 1, 1. Okay, so this will be your 0, 1, 1. This is your 1, 0, 0. This is your 1, 0, 1, and so on. Okay, so these are your /27 networks. So we take the first /27 network and use it for Singapore. Okay, so this will be for /Singapore. And you continue your subnetting. Okay, remember KL. So KL will need how many hosts? KL will need, okay, let's look at KL. Okay, I forgot how many hosts that KL needs. Okay, KL, Jakarta, and Sydney needs 12 hosts. Okay, so KL will need 12 hosts, so a /28 mask would be just nice. Okay, then this is how you do subnetting. If you do it properly and correctly, you should be able to get all the subnet address and the network mask according to Appendix A. Okay, the appendix give you the subnets for Perth, Singapore, KL, Jakarta, and Sydney. Okay, plus a 4 WAN address. Okay, so if you're able to do your subnet well, you should be able to get all these addresses. Okay, I leave this blank for you. Okay, and hopefully you can get the answer for the 4 WAN address. Okay, later I'll show you the answer, okay, in the packet tracer file. Okay, so there's a part 1 of the lab exercise, which is the important part, is to do subnetting.